In this video, we're going to take this series and try to rewrite it as a geometric series or put it into the geometric series form. Now, the thing for us to notice is what we have sitting there in our series function are two constants. We have a 5 and a 4, but more notably, those constants are being raised to powers of n only. As in, we don't have any other terms that are there. Everything looks like constants raised to powers of n. And that sort of signals to us that, hey, this is actually a geometric series that we can do some mathematical massaging through algebra to put it into its more standard form. So let's go ahead and start doing that. And what I like doing for these types of problems, again, we're really just going to use a lot of algebra, is I like breaking these constants to powers of n and just trying to simplify as much arithmetic as I can. So what I mean by that is, for example, if we look at this 5 to the n plus first term, I'm going to break this into a 5 to the n times a 5 to the first term, just so I know the stuff with n's attached, the stuff without n's attached to it. And similarly, we can do that for the 4 to the minus n minus first term. We can write that as a times 4 to the minus n times a 4 to the minus 1. And now we can start to simplify some of this stuff. So we have the series from n equals 1 to infinity. We have constants, just a 5 to the first power and a 4 to the minus first power, which we can rewrite as a 1 over 4. So this really looks like, hey, we have something that's a 5 times a 1 over 4 as sort of the constant terms in our geometric series, or the terms without any n's attached to them. Similarly, we can take what's left over here, this 5 to the n, and this 4 to the minus n, and start trying to do a little bit of algebra with those. So we have this 5 to the n, and now, because that 4 is to the minus n power, we can write that as divided by 4 to the n. So let's just do a little more arithmetic here. This first term we have is a 5 over 4. And that's, again, our term without any n's attached to it. And next, what we see is we have this 5 to the n divided by 4 to the n. Since both the numerator and denominator are raised to the same power, we can write that as a fraction as a whole. So 5 over 4 raised to the nth power. And now we're getting really close to having our series in the geometric series form. But the only difference is, in the geometric series form, we need a constant times r, another constant, but raised to the n minus first power. In this problem so far, we have just an nth power here. So the last little bit for us to do is use a little bit more algebra to factor out 1 5 over 4 from that 5 over 4 to the nth power. So we have a 5 over 4, the original one from the previous line. We can factor out a 5 over 4. And now we have the 5 over 4 raised now to the n minus first. And that minus first is there because we factored out one factor of 5 over 4 from that 5 over 4 to the n that was in the previous line. So what that means for us now is, looking at this, oops, lost a 1. Looking at this, we have a different constant sitting in front of this series. But now we have this other term, a 5 over 4, raised to the n minus first. So we're almost in the geometric series form. So 5 times 5 is 25. All over 4 times 4 is 16, times a 5 over 4, that raised to the n minus 1. So in this problem, that 25 over 16 is our a. And our r is this 5 over 4. So in asking the question of, does this geometric series converge or diverge, we take the absolute value of r. In this case, it's 5 over 4. And well, 5 over 4 is greater than 1. So what that tells us is this series is divergent. And it's divergent because the absolute value of r was greater than 1. But the thing to recognize in this problem is the fact that in the original series that we were given, we only had constants raised to powers of n. And whenever we have that case, we can always use some algebra to put this into the more standard geometric series form. And from there, we can apply the geometric series test and ask, hey, is the absolute value of r greater than 1? Which means the series is divergent, like in this case, or if that absolute value of r is less than 1, the series would be convergent.